Ever wondered what happens when you hit the brakes in your car? It's more than just about stopping. Car brakes are an intricate system, a marvel of engineering that often gets overlooked. There are silent guardians when we're on the road, and yet most of us know so little about them. Think about it, when was the last time you pondered the mystery of car brakes? It's time we shed some light on this essential part of our vehicles. Stay tuned to uncover the fascinating world of car brakes. Dive into the basics to understand how car brakes actually work. The braking system of a car is a complex network of precision engineering, but we'll simplify it for you. At its core, the braking system consists of the brake pedal, brake lines, and brake fluid, all working in harmony to bring your car to a halt. Let's start with the brake pedal. This is your direct line of communication with the braking system. When you press down on the brake pedal, you're actually setting off a chain of events that result in your car slowing down or stopping. The brake pedal is connected to a master cylinder, which is filled with a special type of hydraulic fluid known as brake fluid. As you press the brake pedal, the master cylinder is activated, forcing the brake fluid through a series of tubes and hoses, collectively called brake lines. This brake fluid acts as a messenger, carrying the force of your foot on the brake pedal to the brakes on the wheels. It's a bit like when you squeeze a tube of toothpaste. The pressure you apply at one end is transmitted to the other end, forcing the toothpaste out. In the same way, the pressure you apply on the brake pedal is transmitted via the brake fluid to apply the brakes. The brake fluid travels through the brake lines to the braking mechanism at each wheel. Depending on the type of brakes your car has, either disc or drum, the brake fluid will cause the brake pads to squeeze against a disc or a drum, creating friction which slows the car down. The beauty of this system is in its simplicity. The brake fluid, being incompressible, ensures that the force you apply on the brake pedal is transmitted almost instantaneously to the brakes, giving you precise control over your vehicle's speed. So, the next time you hit the brake pedal, remember the complex process that it triggers. It's not just a pedal, it's a marvel of engineering that keeps us safe on the road every single day. Scene script. Have you heard of hydraulic brakes? They're more common than you might think. The world of brakes is truly fascinating, and hydraulic brakes are a testament to that. These are the type of brakes you'll find in most modern vehicles you see on the roads today. They're a marvel of engineering, bringing together the principles of physics and the power of liquids to help us stop our cars safely. So what exactly are hydraulic brakes and how do they work? Well, let's dive right in. At the heart of it all is the concept of hydraulics. Hydraulics is a branch of science that deals with the mechanical properties of liquids. It's the principle that allows a small force applied at one point to be multiplied into a larger force at another point. Now let's see how this principle is applied in our hydraulic brake system. When you press down on the brake pedal, a piston in the master cylinder is activated. This piston pushes brake fluid through a series of tubes and hoses to the brake cylinders at each wheel. The real magic happens when this high-pressure brake fluid reaches the brake cylinders. Inside each cylinder are more pistons which are forced outward by the fluid. These pistons, in turn, push the brake pads against the brake rotors, creating friction. This friction is what ultimately slows down and stops your vehicle. The beauty of this system is that it multiplies the force you apply on the brake pedal, making it easier to bring your vehicle to a halt. It's an elegant solution that leverages the incompressible nature of liquids to deliver reliable and efficient braking power. But, of course, like any system, hydraulic brakes are not without their challenges. They require regular maintenance to ensure the brake fluid is clean and free of air bubbles, which can compromise the braking efficiency. Despite these challenges, hydraulic brakes have stood the test of time, proving their worth in countless vehicles around the world. They're a testament to our ingenuity and our constant pursuit of safer, more efficient ways to stop our vehicles. Hydraulic brakes, a marvel of engineering that keeps us safe on the roads. Disc brakes or drum brakes, do you know the difference? Well, let's dive right in. First, let's consider disc brakes. They're named for the disc or rotor that spins with the wheel. When you step on the brake pedal, a caliper clamps onto this disc, creating friction and slowing the vehicle down. One of the most significant advantages of disc brakes is their ability to dissipate heat quickly. This makes them less prone to brake fade, a condition where brakes lose effectiveness due to overheating, especially under heavy usage. They also perform better in wet conditions, as they can shed water more efficiently than their drum counterparts. Generally, you'll find disc brakes on the front wheels of most modern cars as they bear the brunt of the braking force. Now, let's shift gears and talk about drum brakes. These operate on a similar principle but in a slightly different way. Here, the brake shoes push out against a spinning drum attached to the wheel, creating friction to slow the vehicle. Drum brakes, while older technology, have their own perks. They're less expensive to manufacture and easier to integrate with a parking brake mechanism. However, they're more susceptible to brake fade and less effective in wet conditions as they can trap water. Typically, you'll find drum brakes on the rear wheels of older or less expensive vehicles. To sum it up, disc brakes offer superior performance, especially under heavy braking and wet conditions, while drum brakes are more cost-effective and have simpler integration with parking brakes. But remember, regardless of the type, the key lies in regular maintenance to ensure optimum performance and safety. So next time you're behind the wheel, think about the intricate dance happening every time you tap those brakes. Whether it's a disc or a drum, each type of brake has its unique role in ensuring our safety. What does the future hold for braking systems? As we hurtle forward into the future, one thing is certain: the world of braking systems is on the brink of a revolution. We're no longer just talking about mechanical components working in harmony to bring your vehicle to a halt. No, the future is all about harnessing the power of technology to make braking smarter, safer, and more efficient. Let's start with regenerative braking. This is a system that's already making waves in the world of electric and hybrid vehicles. Rather than wasting the energy generated during braking as heat, regenerative braking captures it and converts it back into electrical power, which can be used to recharge the vehicle's battery. This not only makes braking more efficient, but also extends the range of electric vehicles, making them an even more attractive proposition. Next up is electronic stability control, or ESC. This system uses sensors to detect when a car is losing grip and is about to skid. It then applies the brakes to individual wheels, helping to maintain control and prevent accidents. It's like having a guardian angel watching over you, ready to step in when things get a little hairy. And then there's brake-by-wire systems. This technology replaces traditional mechanical and hydraulic links with electronic controls, making braking more responsive and precise. It's a bit like swapping out an old dial-up modem for a high-speed broadband connection. Everything just works smoother and faster, but that's not all. We're also seeing the emergence of predictive braking systems which use radar and camera technology to anticipate potential hazards and apply the brakes automatically. Think of it as your car having its own crystal ball, helping to keep you safe on the road. As technology advances, so does the brake system, ensuring safer commutes. So, buckle up and get ready for a future where brakes are smarter, more efficient, and packed with technology that not only saves energy, but also lives. The future of braking systems is bright, and it's speeding towards us faster than you might think. Let's take a moment to recap what we've learned today. Our journey began with the mystery of car brakes. We unveiled the secrets behind the mechanism that makes our cars stop on a dime and how this essential part of every vehicle is often overlooked. We then dove into the basics of car brakes, understanding that they operate on a simple yet effective principle of friction and heat dissipation. We discovered how pressing the brake pedal initiates a chain of events that ultimately brings the car to a halt. Our exploration continued as we unmasked the workings of hydraulic brakes. We learned how they use the power of fluid dynamics to transfer the force from your foot to the wheels, stopping the car efficiently and smoothly. The disc versus drum brake debate was another exciting part of our journey. We discussed the pros and cons of each, realizing that while disc brakes offer better heat dissipation and performance, drum brakes can be a cost-effective solution in certain scenarios. We then shifted gears to the future of braking systems, discussing advancements like regenerative braking and electromagnetic systems that promise to make our rides safer and more eco-friendly. Next time you're in a car, remember the science and engineering behind every press of the brake pedal. Stay safe and keep exploring.